In this video, I will introduce the wrapping function. So let us begin with the idea of a function. So let t be the radian measure of an angle. For every t, there is a unique point P with coordinates xy. So that is in fact the part that is the function. For every length t, okay, t is the radian measure of an angle, that t has a corresponding point, or we can assign a point to that t, and that point is going to be the end point of the arc, and our arc has length t. So let us again refresh your understanding of a function. A function is a mapping, it is pairing, it is matching. You are matching the elements of this set, which is the set containing all possible angle measures of your angle. And that angle measure is given in terms of the length of the arc. And each of these t's are matched to an endpoint, the endpoint of the arc. And that endpoint has a pair of coordinates which we call xy. Okay, so I am opening GeoGebra, and through the help of this software, you can see what I am talking about. Let's say, for example, we have an angle PCA. So if we want to produce an angle with a particular angle measure, and that measure is in terms of radian measure, so what we do is we rotate our terminal side. While we are rotating the terminal side, that rotation is actually tracing an arc in our unit circle, and that arc has a corresponding length. In fact, the value of t here is the length of our arc. So let's say, for example, the length of our arc, or the radian measure of our angle, is pi over 3. So pi over 3 is approximately 1.05. That's it, 1.05. When t is 1.05, the endpoint of that arc is P, and these are the coordinates of your point P. When t is equal to 0.52, 0.52 is the approximate value of pi over 6. So when t is pi over 6, the endpoint of that arc is P with coordinates 0.87 and 0.49. When our arc length is pi over 2, which is approximately 1.57, the endpoint is P with coordinates 0.1. When our arc length is pi, look at that, 3.15 or 3.14. The corresponding endpoint for that arc is P with coordinates -1 and 0. So here you can now see that for every arc length, which is the radian measure of your angle, there is a corresponding endpoint with coordinates x and y. And by the way, our angle need not be in the counterclockwise direction. We can move our angle clockwise. When our rotation is counterclockwise, the angle is positive. When our rotation is clockwise, the angle is negative. So that is the function part of the wrapping function. So where is the wrapping part of the wrapping function? You know what wrapping means. Wrapping is like wrapping paper. So where is the wrapping here? Where is the wrapping paper here? Well, for the moment, what I want you to do is forget about angles, forget about triangles, forget about right triangles. And for now, we shall only think about two things: the unit circle and the real number line. But we are drawing the real number line vertically, whose origin is going to be at point A. Okay, so this is a unit circle with radius 1, and that is the origin of our vertical real number line. Okay, so this is what I'm going to do to the real number line. I'm going to coil it. Coil like a wire. You coil a wire around something. So what I'm going to do is I'm going to coil this real number line around the circle like it's an electric wire. So I will coil the positive part of the real number line. So that's going to move around the circle. So this is going to move around the circle counterclockwise, the positive side of our real number line. Okay? And the negative part of our real number line, I'm going to coil it around this circle. So it's going to coil around the circle in clockwise direction. So in effect, we can wrap the entire real number line around the circle. So that is the part on the wrapping function. We have a unit circle and we will wrap the real number line. We will coil it around the circle. Circular functions. We had spoken a lot about right triangles and trigonometric functions. But for now, we stop thinking about them. We only think about the unit circle and the real number line. Let W be the wrapping function defined by W of t is equal to a point with coordinates xy, where t is a real number and p is a point in our unit circle. Well, what that means is, if t is a real number, there is a corresponding point for that. There is a corresponding point in the unit circle which is paired to that real number t. And that p is the endpoint of an arc with length t. And we shall define our trigonometric functions differently. And this is the reasons why we call it circular functions now. So given this function, the wrapping function, wherein we are matching a real number to a point in the circle, in the unit circle. This point is the endpoint of an arc whose length is equal to t. Well, these are the circular functions. Sine of t is equal to y. Cosine of t is equal to x. Tangent of t is y over x. For as long as x is not equal to 0, and cosecant of t is 1 over y, secant of t is 1 over x, cotangent of t is x over y, where y is not equal to 0. For cosecant, of course, we are assuming that y is not equal to 0, and for secant of t, we are assuming that x is not equal to 0. This is a big change. This is a big change in our understanding of sine, cosine, tangent, and the reciprocal of these functions. Because this is no longer about the right triangle. This is no longer about SOHCAHTOA. This is no longer about an angle, because our t here is no longer just an angle. It's a real number. It's a real number t. So this is quite a journey, because we started studying trigonometry in relation to right triangles, the ratios of the sides, and then we went as far as obtaining the equivalent radian measure of a degree measure of an angle, but now this is gone. When we talk about sine, cosine, tangent, cosecant, secant, and cotangent, we are now talking about the real number line and the corresponding point that we assign to any real number t. That point has a set of coordinates. The y-coordinate of that point is sine of t. The x-coordinate of that point is cosine of t, so on and so forth.